So let us start the next problem, problem number 3 in Nyquist plot, that is obtain the Nyquist plot and comments on stability. Obtain a Nyquist plot and comments on stability. For the open loop transfer function, g of s h of s will be equal to k divided by s into s plus 1 into s plus 2. So this is a problem. As usual, the procedure is you have to calculate poles at RHS and encirclements about the critical point minus 1 plus J0. Let us start the solution. The first thing what we have to calculate is poles. Poles are the denominator factors you have to equate to 0, then s is equal to 0, s plus 1 is equal to 0, s plus 2 is equal to 0. So then you will get 0, minus 1 and minus 2. These are the poles. Then zeros, there are no factors in numerator, hence the poles at RHS will be equal to nil. Then let us try to write Nyquist plot in g of s, h of s, s plane. Nyquist plot in s plane. According to the Nyquist criteria, the encirclements about the critical point minus 1 plus j0 will be equal to number of poles on right hand side of s plane. So encirclements about the critical point n minus 1 plus j0 will be there at g of s, h of s plane, and poles at RHS will be equal to s plane. Let us plot. So here the case is there is a pole at origin. So this is a real axis and this is an imaginary axis and this is a s plane. First I will locate the poles. So there is a pole at origin and pole at minus 1 and pole at minus 2. So since there is a pole at origin, we will take a contour. So this is segment 1 OA and this is segment 2 ABC and this is segment 3 CD and this is segment 4. So segment 1, segment 2, segment 3 and segment 4. Segment 2 is a circular contour. Since it is a circular contour, the radius r e to the power of j theta, where r tends to infinity, and this is a small circle, small e to the power of j theta, r tends to 0. So this is the Nyquist plot in s plane. So heading I will write Nyquist plot in s plane. So why we have written this? To find out PRHS, how many poles at right hand side? So right hand side there is no poles, 0, hence open loop stability exists. After this we need to convert Nyquist plot in s plane to Nyquist plot in g of s, h of s plane. The process for transformation of Nyquist plot in s plane to Nyquist plot in g of s, h of s plane is called as mapping. So the next procedure is mapping. Mapping, the first thing is segment 1. What is segment 1? OA. So in the segment 1, it is similar to a polar plot. Replace s is equal to j omega. Omega varies from 0 to infinity. So g of j omega, h of j omega will be equal to, same thing, where is s? Replace all the s with j omega terms. So s j omega into j omega plus 1 into j omega plus 2. So this is replace s with j omega, then find out the magnitude. Magnitude for this is, magnitude for numerator is k, square root of k square. Square root and square get cancels, you will get k. Denominator omega, omega square with root, it is omega. Then real part is 1 square plus omega square. So omega square plus 1 and this is omega square plus 2 2s are 4. Magnitude is nothing but square root of real part square plus imaginary part square. The same thing I have applied here. Then phase angle, directly I will write numerator it is 0, denominator omega will be there. Omega by 0 is infinity. Tan inverse of infinity is 90 degree. Since it is located at denominator, it is minus 90 degree. So minus 90 degree minus tan inverse of omega by 1. So tan it is just omega minus tan inverse of omega by 2. So this is the equation for magnitude as well as phase angle. Then what is the magnitude when omega is equal to 0? So omega 0, anything by 0 is infinity. What is the magnitude at omega is equal to infinity? It is 0. Then phase angle at omega is equal to 0 is minus 90. Phase angle at omega is equal to infinity is, this is infinity, minus 90, minus 90, minus 90. So it will be minus 270. So this is about the first segment of the polar plot. Then second segment, what is the second segment? Segment 2. Segment 2 is ABC. ABC is you are searching entire right half of the S-plane. Hence it is a plot of circular contour. Since it is a circular contour, we have defined a special function. So hence replace S is equal to R e to the power of j theta, where R tends to infinity. After that, theta varies from, theta means angle varies from the same line, minus 270 degree to minus 450 degree. Angle coverage, theta is equal to 180 degree clockwise. So this is 180 degree clockwise. Hence g of r e to the power of j theta, h of r e to the power of j theta will be equal to k divided by r e to the power of j theta into r e to the power of j theta plus 1. This one I have written again, r e to the power of j theta plus 2. After that, consider r tends to infinity. So you are just considering the limit. If you consider the limit, k divided by r e to the power of j theta. Here also, compared to this, 1 is small. So retain r e to the power of j theta. Here also, compared to infinity, 2 is small. So r e to the power of j theta. So r into r into r, again infinity into infinity into infinity, again it will be a constant. Now apply r tends to infinity. Now I am applying the limit. Then it will be k divided by r e to the power of minus 3j theta. At this point of time, you are able to write this function directly. E to the power of j theta, e to the power of j theta, e to the power of j theta. It is having a same base, only the change is index. So it will be get added up. J theta plus j theta plus j theta, it will be 3j theta. If you take that to a numerator, it will be e to the power of minus 3j theta. Then let us see what is the magnitude. Magnitude at r tends to 0. Magnitude at r tends to 0. So very careful here. What is the magnitude here? Magnitude is always, you have to take, r will be at always infinity, not 0. For the segment 4, it is 0. This point, always there is a confusion. So be careful. By seeing this plot, r tends to infinity, you can easily keep that in your mind. So this is infinity. It will be 0 because anything by infinity is 0. Then what is the phase angle? Phase angle is minus 3 theta. How minus 3 theta? E to the power of minus 3j theta can be written as cos 3 theta minus j sin 3 theta. And if we take phase angle for this, it is tan inverse of sin 3 theta divided by cos 3 theta, tan inverse of minus tan 3 theta. So inverse and tan will get cancelled. you will be left out with minus 3 theta. This calculation I will put here. So minus 3 into 180 degree. So it is minus 440 degree. Since you got minus, the sign is opposite to 180 degree. So here it is clockwise. It will be 540 degree counterclockwise. So this point and this point are important. When you get minus, the direction will get reversed. Then segment 3, directly I will write segment 3, it is CD. Again omega varies from minus 0 to infinity. Replica of segment 1. Both are same, only the mirror images. The same thing you can write it in exam, no problem. You need not solve this. Then segment 4, very important. Segment 4 is again a circular contour in counterclockwise direction, but the radius will be infinitesimally small. You have taken a small bypass since there is a pole at origin. Segment 4, it is DE bow. Replace S is equal to small r e to the power of j theta, where small r tends to 0 and theta varies from 270 degree to 450 degree. What is the angle coverage? Angle coverage will be theta, it is 180 degree. 180 degree, how it is covering? It is covering in counterclockwise direction. 180 degree counterclockwise. Then G of r e to the power of j theta, h of r e to the power of j theta will be equal to k divided by r e to the power of j theta, r e to the power of j theta plus 1, r e to the power of j theta plus 2. So again consider r tends to 0, very important thing here. Always this step is important. R tends to 0. So here k divided by r e to the power of j theta, compared to 1 and 0, which is small, 0 is small, take greater one. So 1, here also 2. So this will be again a constant. Consider now, apply r tends to 0, then k by r e to the power of minus j theta. So what is the magnitude? What is the magnitude when r tends to 0? It is infinity. And what is the phase angle? Phase angle will be equal to again minus theta. How? E to the power of minus j theta is cos theta minus j sin theta. So phase angle will be equal to tan inverse of minus sin theta by cos theta, tan inverse of minus tan theta, it is minus theta. I have written here. So minus theta directly I will write 5 will be equal to 180 degree. What is the direction? So here you have to look. It is counterclockwise. Since you got negative, it is clockwise. So this is about the mapping. There are 4 segments. For the 4 segments, you have converted the Nyquist plot in S plane to Nyquist plot in G of S, H of S plane. After this, what is the thing I have to do? I have to draw Nyquist plot in G of S, H of S plane. So Nyquist plot in G of S, H of S plane. So first I will write G of S, H of S plane, then this is a real part sigma and this is an imaginary part j omega. So the first thing is I have to write for first segment. What is the first segment? Segment is OA. OA. First I have to locate what is the angle. What is the angle here? Minus 90 degree. I have to locate minus 90. So 0, minus 90. So this is minus 90. Then minus 180, minus 270, minus 360. So since it is minus 90, it is starting somewhere here. Then minus 270 here. So it will be moving from this to this end to this end. And what is the angle coverage? Minus 270 minus of minus 90, it is 180. 180 you got minus. Minus indicates the plot should go in clockwise direction. So here there might be chances of going like this or going like this. So if you take like this, it is counterclockwise direction. The plot should go in clockwise because the angle coverage minus 270 minus of minus 90, it is minus 180 degree. Minus indicates clockwise. So this is the correct plot. So this is a OA. This is a first segment. Then after that, the second segment is magnitude will be 0. It is almost nearer to 0. And what is the angle coverage? Angle coverage is 540 degree. So there are several angle coverages. If it is 90 degree, just a straight line. If it is 180 degree, this is angle coverage. This is 180 degree. If it is 360 degree, a circle. If it is 540 degree, a line, this is 90 degree, and then a circle, this is 360 degree, and again a line 90 degree. So 360 plus 90 is 450, 450 plus 90 is 540. So this is how the plot will go. The same thing what you have solved in first problem. This is 540 degree. I will write 540 degree. First straight line, then a circle, then a straight line. This is 540 degree and this is a segment 2. Segment 2 will be moving in counterclockwise direction. Why means it is 540 degree counterclockwise direction. See here, first it will go like this. The direction of second segment is always counterclockwise. So this is segment 2. Then segment 2 is A, B, C. Segment 3, it is a replica of segment 1, hence the same plot in a reverse direction. This is segment 3, CD. What is the segment 4? Segment 4 is magnitude infinity. Magnitude infinity means you are at infinity here. So this is infinity. And see this, you want to close this. Always you will get a closed plot. Here, if you close this, the direction of the plot is clockwise direction. The angle coverage is 2 quadrants. 2 quadrants means 180 degree. Is it correct? Yes, 180 degree clockwise. So this is the closing plot. This is segment 4, DEO. 180 degree clockwise. After plotting this, first you have to find out whether the plot is crossing negative real axis or not. Is it crossing negative real axis? Yes. The first segment is crossing negative real axis and third segment is crossing negative real axis. Sir, the second segment is also crossing negative real axis. But since we have taken a bypass for second segment, the radius of the second segment will be infinitesimally small. So this plot consideration we will not take. Hence, only first segment and third segment is crossing the negative real axis, because of which you have to locate the critical point minus 1 plus j0 here. The same what we solved in first problem, the same case. I will write the sentence, since the polar plot, or just since there is an encirclement about negative real axis, hence critical point minus 1 plus j0 is to be located. So this is the condition. How to locate critical point? So to locate minus 1 plus j0 critical point. How to locate minus 1 plus j0 critical point? So the condition is at minus 1 plus j0. At minus 1 plus j0, the condition of magnitude will be equal to 1. Either you can use the magnitude condition or you can use the phase angle condition. What is a phase angle? Phase angle will be the equation what you have solved, this you have to take, it will be minus 90 minus tan inverse of omega minus tan inverse of omega by 2. This is a phase angle what you have to consider. So see here, open loop transfer function, the phase angle for open loop transfer function is this. At critical point, the phase angle will be minus 180 degree and omega is equal to omega p. This is the condition what we have obtained. At omega is equal to omega p, the phase angle is minus 180 degree. So that means we are calculating what is the phase crossover frequency. So let us apply this condition. Minus 180 degree will be equal to minus 90 degree minus tan inverse of omega minus tan inverse of omega by 2. Next condition, I will take 90 degree here, minus 180 minus 90. Sorry, minus 180 plus 90. It will be minus 90 degree is equal to minus tan inverse of omega minus tan inverse of omega by 2. Once you apply phi is equal to minus 180 degree, the omega will be always omega p. Very important thing, because it will be phase crossover point. Then multiply by negative and take tan on both sides. It will be tan 90 will be equal to tan of tan inverse omega p plus tan inverse omega p by 2. So it will be in the form of tan of a plus b. This will be a and this will be b. What is tan of a plus b? Tan of a plus b is tan a plus tan b. Tan of a plus b, tan a plus tan b divided by 1 minus tan a tan b. This is a formula. The same thing I will substitute here. So tan inverse of 90, tan 90 is infinity, it is 1 by 0. Tan of tan inverse, tan a, tan of tan inverse omega p. So tan and tan inverse get cancels, it will be omega p only, plus tan a plus tan b. Tan b is omega p by 2 divided by 1 minus omega p square by 2. 1 minus omega p square by 2. I will take this 1 minus p square omega p square by 2 equal to 0. So what is 1 minus omega p square by 2? Equal to 0. So it will be, if I replace this, I will get 2 minus omega p square will be equal to 0. Omega p square is equal to 2. Omega p is equal to square root of 2 radian per second. So this is the phase crossover frequency what we have got at critical point. In your calculator you can use solve, directly you will get this step. Solve, you fetch this equation, give this value, you will get this. Then after this it's a basic trigonometry, the same thing, first problem how you have solved. But there is a variety here, I will tell you. What is the magnitude? What is the magnitude here? Magnitude will be same thing, k divided by omega p into square root of omega p square plus 1 omega p square plus 4. What is the magnitude here? You calculate magnitude at phase crossover point. Specifically I will write magnitude at phase crossover point. Then k divided by, here it is root 2, here root 2 square, it will be 2, 2 plus 1, 3, here root 2 square, again 2, 2 plus 4 is 6. So this is the value of k. So what is the value of k here? 6 3s are 18, 18 2s are 36, square root of 36 is 6. So magnitude will be k by 6. So in the first problem you are getting directly what is the value of magnitude. In the first problem you are getting what is the value of magnitude directly. But here the value of magnitude is depends upon the value of k. What is the value of k here? We don't know. K might be a positive number or k might be a negative number. Let us assume k is a positive number. What is the value of k? If k is equal to 1, magnitude will be 1 by 6. If k is equal to 10, magnitude will be 10 by 6. 1 by 6 is less than 1. 10 by 6 is greater than 1. How will you conclude the system is stable or not? This is a challenging in this problem. So what we have to do here is, if I assume k is equal to 1, the magnitude will be 1 by 6. Got it? The magnitude will be equal to 1 by 6. And if I assume k is equal to 0, the magnitude is equal to 0. If I assume k is equal to 10, magnitude will be 10 by 6, which is greater than 1. What, for ease of purpose, what I will do is, the magnitude will be less than or equal to k by 6. If I write like this, I have to solve for all the cases. What cases I have to solve? I have to solve what if magnitude is less than k by 6? What if magnitude is equal to k by 6? What if magnitude is greater than k by 6? So, very important thing, this problem. So, how to analyze this problem? Very important. We don't have an exact value of magnitude. First, let us take a case of magnitude less than 1. If the magnitude is less than 1, the critical point what you have got, the critical point minus 1 plus j0 will be after the plot. So, this I will take as A. So, this is minus 1 plus j0 will be after the plot. What is the magnitude here? Magnitude of this plot is less than 1. Got it? If you are locating critical point after the plot means here you have a magnitude circle 1. Got it? This circle is having m is equal to 1, but this plot is having magnitude less than 1 because it is far away from minus 1 plus j0. So, we need to add this amount of magnitude in order to make magnitude will be equal to 1. So, in other words, if the magnitude is less than 1, the critical point will be located after the plot. This is the first case. What about if the critical point is on the plot? This is the second case. I will call it as x. Critical point is on the plot. Another case, if the critical point is before the plot. So, this I will call it as B. So, I have taken all the three conditions. Let us analyze. So, just I will write magnitude conditions or stability considerations because I am basically commenting on stability. So, first I will take case 1. If magnitude is less than 1, then critical point minus 1 plus j0 is after the plot. Again, it is self-explanatory. After the plot, hence, according to Nyquist criterion. What is Nyquist criterion? Therefore, n minus 1 plus j0 is equal to z RHS minus p RHS. Z RHS will be 0. N minus 1 plus j0 is equal to minus p RHS. So, what is n minus 1 plus j0 here at this point? There is no encirclement here. There is any encirclement? No. So, 0 here. 0 will be equal to 0. Since LHS is equal to RHS, system is stable. In the first case, the system is stable. When it is stable, if the magnitude is less than 1. Why? the critical point will be located after the plot. After the plot, there is no encirclement. At this point, whether any polar plot is crossing here? No. That's why it is 0 or nil. Then, second case, if, so what I will be writing here is critical point, here I have taken A. Just for a understanding purpose, I have named it as A. Second case, if magnitude is equal to 1, then critical point minus 1 plus J0, which is that X is on the plot. If it is on the plot, directly you can write the system is neither stable nor unstable. The system is neither stable nor unstable. Directly you can write, no need to calculate n minus 1 plus J0. Next, number 3. If magnitude is greater than 1, magnitude is greater than 1 means the magnitude of this plot is greater than 1 means minus 1 plus J0 is before the plot here. So, then critical point minus 1 plus J0 B is before the plot. If I consider this here, there is an encirclement. So segment 1 is crossing negative real axis and segment 2 is crossing negative real axis. In other words, segment 1 is crossing B and segment 3 is crossing B. That means, therefore, n minus 1 plus J0 is equal to Z RHS minus P RHS. This will be 0. N minus 1 plus J0 is equal to minus P RHS. P RHS value is 0, that you know. What is the Z RH? N minus 1 plus J0? It is 2. So here n minus 1 plus J0 at A equal to 0. N minus 1 plus J0 at B is equal to 2. You have two encirclements. See here, segment 1 and segment 3. So you got 2, but 2 is not equal to 0. LHS is not equal to RHS. System is unstable. Why this analysis? Before, in the first problem, can we done all these things? No, because we know the magnitude of the plot directly. The magnitude of the plot was about some value. By seeing the value, we have located the critical point minus 1 plus J0. But here, they have not given any value. The value is in terms of K and the value of K is unknown. And the value of K might be positive or might be negative. Let us assume it is a positive. If I assume it as positive, then these are the three things what we have to do in order to calculate the stability of the system. Here, another thing importantly here is we have calculated magnitude less than 1, magnitude is equal to 1, magnitude is greater than 1. We have taken all conditions, we have interpreted the relation here. So, after this, in the problem, sometimes they will mention what is the value of K for the stable system. Sometimes they will not mention. If it is not mentioned means, if you won't determine the value of K, you will lose marks. If it is not mentioned also, you have to write what is the value of K. What is the value of K for stable system? Value of K for stable system. So let us consider the magnitude again. Magnitude will be equal to K by 6. Magnitude will be equal to K by 6. And what is the magnitude here? I will just consider the second case. If the magnitude is equal to 1, it is K by 6 and the value K will be equal to 6. Is K will be equal to 6 is a stable system? No. When you got K is equal to 6, when you equate magnitude 1. Got it? So this is a value of k at which the system is neither stable nor unstable. Neither stable nor unstable. But if the value of magnitude is less than 1, then the system is stable. If you want to make the value of magnitude is less than 1 means it should not exceed the denominator. The value of k, if it is equal to 6, if k is equal to 6, 6 by 6 becomes 1, magnitude will become 1. If the value of k is 7, magnitude will be more. So the extreme value of k for a stable system can be 6. At 6, it will be neither stable nor unstable. Then you can conclude that for the stable system, the magnitude should be less than 1. In order to get the magnitude less than 1, the value of k should be less than 6. Therefore, for stable system, this is a condition, the value of k should be lies in between 0 and 6. If it is equal to 0, magnitude will be equal to 0, then there is no question about stability. If it is equal to 1, 1 by 6, you will get some value, but the magnitude will be less than 1. If the magnitude is less than 1, always critical point will be located after the plot only. So that means there is no encirclement about the critical point. Hence, n minus 1 plus j0 will be equal to 0 and P RHS will be equal to 0. 0 is equal to 0, LHS is equal to RHS. The system is stable. So this is a condition. If the value of k is more than 6, the magnitude will be more than 1. If the magnitude is more than 1, then minus 1 plus j0 critical point will be inside the plot or before the plot itself. Therefore, the system will become unstable because there will be two encirclements when you consider critical point at B, two encirclements. If you equate 2 with P RHS is having 0. That means there is no poles on right hand side of the S plane. Hence 2 is not equal to 0. The system will be unstable. So this is a problem having all the cases of magnitude and you can solve this problem easily. But the things looks complicated here. Nothing is complicated. First we started with an open loop transfer function. Open loop transfer function g of s, h of s, the same thing. No modification since they have given open loop transfer function itself. Calculated poles, calculated zeros. Then we calculated the Nyquist plot in S plane. Why Nyquist plot in S plane? To calculate P RHS. Here we got P RHS. Then we have to convert Nyquist plot in S plane to Nyquist plot in G of S, H of S plane. For that we have done mapping. Mapping is a transformation of Nyquist plot in S plane to Nyquist plot in G of S, H of S plane. So the same thing we have done. After mapping, the procedure will be remain same, segment 1, segment 2, segment 3. In S plane there is only two cases. Pole at origin, no pole at origin. Here it is a case of pole at origin, a small bypass you will take. That's all. Then these are the procedure. Then we plotted Nyquist plot in G of S, H of S plane. This is analogous to a first problem. First you locate the angles of a segment, then you try to plot. Try to analyze the direction, it will be easy. Then after that, you will be seeing whether there is any encirclements. Here there is any encirclement. Yes. Segment 1 and segment 3 are crossing negative real axis. Hence, there might be encirclements at critical point. But we still not know whether there is an encirclement or not. Before that, we have to locate minus 1 plus j0. So, hence we have located minus 1 plus j0. The condition for that is, you can use either magnitude condition or phase angle condition. If I use magnitude condition, magnitude will be equal to 1. If I use phase angle condition, phase angle at phase crossover frequency will be equal to minus 180 degree at omega is equal to omega p. Find out what is the magnitude at phase crossover point. Magnitude at phase crossover point you have to find out. Before that, locate phase crossover point. Phase crossover point frequency you have calculated. It is √2 radian per second. After that, calculate magnitude at phase crossover point. So this is magnitude at PCP. Magnitude at PCP. You have calculated. This is the magnitude at PCP. The value of magnitude will be k by 6. We don't know the value of k. That is a surprise here. We don't know the value of k. Shall we leave this problem? No, we have to solve. We have to analyze the stability. 7 marks will be dedicated for that. How to solve that? These are the conditions. First, I have calculated the magnitude value. This is the how? K by 6. Denominator part we can easily simplify it. We got k by 6. After that, we have used 3 points. 3 points means point A, point X and point B. Point A is assuming critical point is after the plot. In other words, first we assume the magnitude is less than 1. That means if magnitude is less than 1, where will be the critical point? The critical point will be after the plot. Got it? So this circle, there will be a circle here. This circle is having magnitude 1. The first class frequency domain specification itself, you have know what is that? M is equal to 1 circle. So here if M is equal to 1 means it will be M less than 1. After this plot, M greater than 1. Got it? That's the concept. So here plot will be here. There is no encirclement about this plot because critical point is here. There is no encirclement here. So that means 0. 0 is equal to 0. The system will be stable. Second case, magnitude at X. The system is neither stable or not stable. Directly you can write, if you calculate that also, the same thing what you will get because it is marginally stable point. Then number 3, M greater than 1. If M is greater than 1 means the magnitude of this plot will be greater than 1. It will be beyond minus 1 plus J0. Hence, the critical point will be inside the plot. That means before the plot. Here, this is a critical point. After the critical point, you have a plot. So, critical point will be located before this plot. That is the meaning of the sentence what I have written. So, this is B. You have calculated what is the encirclement. Yes, there is a 2 encirclement. Segment 1 is crossing and segment 3 is crossing. Hence, you have a 2 encirclements. But P RHS is 0. But LHS is not equal to RHS. The system is unstable. LHS is not equal to RHS. And then value of K. What is the value of K for stable system? What is the condition of magnitude for the stable system? The magnitude should be less than 1. Less than 1. What if magnitude equal to 1? We have calculated the value of K. We got K is equal to 6. K is equal to 6. If you give, then it will be 6 by 6. It will be 1. Magnitude 1 is neither stable or not stable. But you have to write the value of K for stable system. The value of K for stable system is the value of K should be less than 6. So this is the problem of Nyquist plot. Very importantly, analyzing the magnitude itself looks bigger, but it is not bigger one. M is less than 1, M is equal to 1, M is greater than 1. That's all. This is the extension of first day concept. If you understand the first day concept, it is very easy. So, thank you.